This program will show the maintenance procedures that should be carried out on the Leyland Tiger coach. Due to the wide variation in vehicle operating conditions, the maintenance frequency, either on a time or mileage basis, may vary for individual operations. To avoid undue complications, this program will highlight all these items of maintenance regardless of the frequency. During the maintenance procedures, always ensure when carrying out running tests that the gearbox is in neutral, the park brake is applied, and the road wheels chocked. Take special care when working in the areas where rotating shafts and cooling fans are installed. If it is necessary to jack the vehicle up, always use suitable blocks or stands. During static maintenance, turn off the battery isolation switch and display a warning notice in the cab. Before proceeding, let's briefly look at the general vehicle specification. The Leyland Tiger is fitted with a horizontal 11-litre 6-cylinder turbocharged engine which is mounted midway in the chassis. The power output can vary according to specification from 170 to 260 brake horsepower. With the transmission system, there are three basic forms of gearbox which can be fitted. First, a 5-speed hydrocyclic unit which has an integral retarder. The drive from the engine to the gearbox is via a fluid coupling. The controls for the gearbox can either be fully or semi-automatic. As an alternative, providing the engine power output is not in excess of 218 brake horsepower, a 5-speed pneumocyclic gearbox with a fluid coupling can be fitted. Again, the gearbox controls can be fully or semi-automatic. To complete the range, a ZF 6-speed synchromesh unit can be installed and, if required, is available with a splitter unit to give 11 or 12 speeds, depending on specification. When this unit is used, a twin-plate Dana Spicer clutch is installed, which is operated by a conventional clutch pedal with hydraulic air assistance. From the gearbox, the power is transmitted via a one-piece prop shaft to a single-speed hypoid rear axle. Moving on to the front axle, this is a conventional beam-type construction. Steering assistance is provided by an integral hydraulic steering unit. Air suspension is fitted to both the front and rear axles, although conventional leaf springs may be used as an alternative. The braking system is of a direct air design, and the foot brake has dual operation to give independent operation to the front and rear brakes. Spring brakes on the rear axle provide a park brake facility. To supplement the braking system, retarder units can be fitted. With the hydrocyclic gearbox, the retarder is combined within the gearbox. However, the pneumocyclic and ZF units can have a Telma retarder fitted either to the rear of the gearbox or in the prop shaft driveline. If no retarder is fitted, the engine will have an exhaust brake installed in the exhaust manifold. The first stage of engine maintenance we should be looking at is oil and filter replacement. You should be aware that there are two drain plugs in the sump which must be removed to carry out a complete oil change. One on the outer sump and one here on the inner. The normal oil change is carried out at 10 to 12,000 mile intervals. However, when the vehicle is delivered new, the engine is filled with a special type of oil to assist the running-in period, which should be drained at 1,000 miles. If the oil is drained too early, the bedding in may not be complete, Particularly in the case of the pistons and rings, this could result in future heavy oil consumption. When draining the oil, whilst not carrying out a detailed oil analysis, always be on the lookout for obvious signs of fuel or water contamination. Fuel will make the oil very thin and be accompanied by a strong smell of diesel. Water will produce either a grey emulsion or separation if the engine has been standing for a long period. The source of these problems must be found. Otherwise, a high wear rate will result on the engine components. And in severe cold conditions, the contents of the sump may solidify, causing complete oil starvation to the main lubrication system, resulting in seizure of the crankshaft. On the TL11 engine, this is the oil filter. And on the top of the filter head are the oil pressure switches for the driver's warning light and oil gauge. When replacing filter elements on earlier models, the bottom filter plate, which is spring-loaded, was not retained in position, and this could remain attached to the discarded element with the result that the replacement filter was not sealed correctly, allowing unfiltered oil to circulate around the engine, causing severe wear, particularly to the crankshaft and turbocharger. On later filter assemblies, this filter plate is retained in position with a small spring clip. To complete the filter replacement, fit a new seal in the filter head and tighten the retainer bolt to the required torque indicated on the filter notice. There is a bypass valve in the filter head to allow unfiltered oil to pass around the oil system, should the filter ever become blocked or severely restricted. The breather is mounted on the engine sump. Access to the breather filter can be gained by removing this pipe. The filter should be cleaned and replaced. If the breather system is not effective, pressure will build up in the engine crankcase, causing oil to leak from the joints or oil seals. The most usual leakage point is either from the crankshaft front or rear oil seals. Moving now to the fuel system. On the Tiger, close to the fuel tank is the primary filter, which collects any large dirt particles or water. This can be drained by a tap on the bottom of the filter. However, if the unit is heavily contaminated, the complete bowl assembly must be removed and cleaned. If the fuel level is high in the fuel tank, to prevent fuel siphoning when the bowl is removed, slacken the input pipe or turn the fuel tap off if fitted. Replacement sealing rings must always be fitted when the bowl is replaced. Otherwise, air may be drawn into the fuel system, causing a vehicle breakdown. The position of the primary filter will vary depending on whether the vehicle has a side or a rear-mounted fuel tank. On the engine, there are two filters which have replaceable elements. However, be sure that the sealing rings in both the filter head and base are changed at the same time. Because the fuel system has been disturbed, it will be necessary to bleed air from the system. The bleed points are here on the fuel injection pump and also on the fuel filter head. If you're required to fit replacement injectors, always fit new or annealed sealing washers. Always clean the injector seats and ensure that you do not over-tighten the injectors, as this may distort the injector body and jam the needle. Make sure there are no leaks from the injectors, particularly from the leak-off pipes and connectors, as this will cause dilution of the lubricating oil. Whilst in this area, check the valve clearances and reset them accurately if required, because if set too wide, it will retard the valve timing and create noise when the engine is running. Alternatively, if set below the recommended clearance, it will advance the valve timing, and in extreme cases, the valve will blow, damaging the valve seating, particularly when the engine is under full load. For example, on the Tiger engine, the valve clearances are 20 thou. If this is reduced by approximately 5 to 6 thou on the exhaust valve when the engine is under full load, the remaining clearance will diminish due to expansion. This results in the valve not seating. You should also inspect for external fuel or oil leaks. Check the security and condition of all external components, such as the fuel injection pump, compressor, manifolds and connections, turbocharger, and all water, fuel, and oil pipes. Drive couplings and shafts to the fuel injection pump and auxiliary gearbox should be inspected. Check the security of the mountings on the engine, the exhaust system, and auxiliary gearbox. Ensure that the fuel injection pump is receiving full throttle. Remember, if it fails to reach the maximum stop, this will result in a noticeable loss in engine power output. Make sure that there are no air leaks from the throttle actuator and that the stop control functions correctly. To complete the engine checks, carefully inspect the crankshaft damper for damage to its outer casing. Any damage in this area may render the unit inoperative and cause an engine crankshaft failure. Another important item of engine maintenance is to inspect the condition of the air intake and filter system. First, check the air restrictor indicator. If it indicates red, this points to either a restricted air cleaner or collapsed air trunking. If the air cleaner element is removed, you should ensure that when it's replaced, all the seals are fitted correctly, both on the filter and on the canister cover, and that the end cover fits correctly. Failure to observe this may allow large quantities of dirt to be pulled into the engine. Careful inspection should be made of the air trunking from the air cleaner to the engine for any restrictions or partial collapse. In addition, carefully check that there are no holes, as even the smallest of holes will allow large quantities of abrasive material to be drawn into the engine, causing severe wear to the engine bores, pistons, and rings. Cases have been known where engines have been rendered unserviceable, with mileages as low as 10,000 miles, and where items such as piston rings have been worn to half their normal thickness. To complete the maintenance on the engine, let's now look at the cooling system. The TL11 engine has a gear-driven water pump at the front of the engine. When the engine is running, water is pumped first to the heat exchanger and then onto the cylinder side door. Having passed round the cylinder bores and cylinder head, the water is collected by a water rail. Providing the thermostat is closed, the water returns to the pump via a bypass pipe. A triple element thermostat is used, which opens at approximately 82 degrees centigrade and allows water to circulate to the radiator at the front of the vehicle. The radiator has a hydraulic fan unit which is driven from the power steering pump on the engine, and Depending on specification, an air-operated radiator shutter may be fitted. There are two sensor units installed in the radiator pipe. This controls the shutter operation, and this signals the hydraulic switching valve to operate the fan. The fan will rotate all the time the engine is running, but at a relatively low speed until the temperature switch cuts in, putting the fan into a full speed condition. Because of remote switching arrangements, extra care should be taken when working near the fan. Installed on the thermostat housing is a temperature transmitter, which operates the driver's temperature gauge. In addition, there is a temperature switch which operates a warning light and buzzer in the cab. Located in the header tank are two probes, which also operate a warning light and buzzer if the water level is too low. This system can be triggered by draining off approximately 1 gallon of coolant. The next area of inspection is on the running function of the cooling system. If the vehicle has been standing and the air pressure is depleted, the radiator shutter will be open. When the engine is started and the air pressure begins to build up, the shutter should close, thus confirming that both the shutter and the actuator are working. A quick test on the engine thermostat is to run the engine for 4 or 5 minutes, and if the thermostat is closed, there should be a noticeable difference in the temperature between the water in the engine and the output pipe to the radiator. The next part of the procedure should be combined with a vehicle road test. During this test, the thermostat should open, allowing water to circulate to the radiator. Therefore, at the completion of the road test, you will find that the radiator shutter should either be open or just about to open. If it is closed, run the engine for a further 2 to 3 minutes. However, ensure during this period that all the saloon heaters are turned off. Next, cover the front of the radiator and run the engine for a further 4 to 5 minutes, during which time the water temperature will increase, which should switch on the radiator cooling fan. During this test, a careful watch must be made in the cab, and if the high temperature light comes on, stop the test, as there is a cooling system fault. To complete the checks on the cooling system, to avoid corrosion in the engine waterways and possible blockage of the radiator, check that the antifreeze mixture is just above 30%. If the antifreeze mixture drops to around 15%, the water mixture becomes acid, even more so than ordinary water. This accelerates the rate of corrosion. To carry out this test, a sample of water should be drained from the vehicle and tested, using a hydrometer together with a special slide rule. Be certain to take into account the water temperature when making your calculations. If antifreeze is not used, an alternative inhibitor such as Stay Clean should be used, which will protect the water system from corrosion. Now let's move to the maintenance of the basic gearbox units. First, the ZF. On the right-hand side of the unit is a combined filler and oil level plug. The gearbox breather is located here and should be checked periodically to ensure that it's not blocked. Look for hydraulic leaks from the clutch slave cylinder, and also for air leakage from the exhaust port, with the pedal in the applied position and in the released position. The system fluid reservoir should also be checked. Although the clutch has a wear compensator, a visual inspection must be made through this inspection cover to check the clearance on the release bearing. If the adjustment is correct, the clearance should be ½ an inch with the clutch engaged. If the wear compensator fails, the release bearing clearance will increase until the release levers contact the pressure plate and cause the clutch to slip. If excess clearance is found, rotate the engine until the adjuster worm is visible. Next, remove this screw completely and slacken off the other. This will allow the adjuster worm to disengage from the adjuster ring on the clutch. Press the clutch pedal down fully to remove the clutch load from the ring. In this condition, the adjuster ring can now be rotated in a clockwise direction to reduce the release bearing clearance. If the ring will not move, the clutch must be removed and rectified. To complete the exercise, check that the worm adjuster spring is not broken, and during reassembly, ensure that the spring engages correctly in the locating hole. Contained in the program's support notes are the details of the clutch lever and linkage settings, which should be checked if no fault is found on the adjuster worm or ring. Now let's move to the basic maintenance of the Hydracyclic gearbox. In order to carry out a complete oil change, there are two drain plugs. The one for the gearbox is in the base of the unit, but for the fluid coupling, it will be necessary to rotate the engine until one of the fluid coupling periphery plugs is at bottom dead center and opposite a convenient inspection aperture in the clutch housing. The oil filter is located here and contains a replaceable element. Always ensure that the correct type is fitted, which will withstand the operating temperatures and pressures. Before replacing the filter, renew the seal in the filter head and lubricate the thread section of the bolt with Shell S-type grease or similar lubricant. Failure to do this may create excessive friction on the bolt thread when it's tightened, resulting in reduced clamping of the seal. Also, in the future, difficulty may be found when removing the bolt because the threads may pick up, causing damage to both the filter head and the bolt. The tightening torque for this bolt must not exceed 55 pounds-feet. With all drain plugs replaced, fill the gearbox with 6 gallons of oil through the combined filler and breather. Start the engine and run for 2 to 3 minutes. Stop the engine and immediately check the oil level. Top up to the upper mark if necessary. Always remember when checking oil levels in service that if the vehicle has been stationary for any length of time, the oil will have drained down from the fluid coupling into the gearbox, lifting the oil level by 1.5 gallons. When the engine is started, oil is drawn from the gearbox to fill the fluid coupling. If the oil is then checked immediately after shutdown, the actual level can be established. Any attempt to check without going through this procedure will give a false reading. After completion of this section of the service, inspect for oil leaks from the filter or from the gearbox in general. All pipe clips should be tight and intact. If this is not carried out, it can result in pipe vibration and ultimate failure. Next, a periodic check on the gearbox operating pressure should be made. However, before proceeding, you should be aware of the two different types of control system which may be fitted to the Tiger. First, there is the LVS system, and the more current direct gear control, both of which provide a semi-automatic function. Where the control is fully automatic, the LVA control is used, or again, more recently, the microprocessor. First, let's look at this procedure on the LVS and direct gear control systems. The pressure gauge is fitted to the pressure test point on the electro-hydraulic valve block. Next, start the engine and note the pressure reading. This should normally be 180 pounds per square inch. However, there will be variations of this pressure in 1 or 2 instances. You should therefore refer to the maintenance handbook for the full range of figures. Should the pressure be too high or too low, minor adjustments can be made by removing this plug and inserting an Allen key. Turn clockwise to increase or anti-clockwise to decrease the pressure. On no account must the screw be turned in fully, as this may render the pressure relief valve inoperative. resulting in high oil pressures in the gearbox. So remember, do not screw the pressure relief valve down too far, as minor adjustment is all that is necessary. Now let's look at the LVA system. Here the gearbox runs at 2 pressures depending on the load placed on the transmission. To check the main pressure, start the engine and place the gear selector in H or R. This will place the gearbox on full pressure. The pressure should be 180 pounds per square inch in most applications, but again there are exceptions. Should the pressure require adjustment, take off this dust cover on the valve unit and remove the center screw and valve lock nut to gain access to the pressure relief valve adjustment. The second pressure, known as attenuated pressure, should be set. To do this, place the change speed in A. The gearbox should now be in the low pressure condition, and the pressure can be adjusted by this screw to give 82 pounds per square inch. But again, there will be exceptions. Now the microprocessor. The gearbox has again 2 operating pressures. To check the main pressure, the gear selector must be in A, H, or R. And to check the attenuated pressure, the gear selector should be in S. The adjustments are again identical. It is important to check the operating pressures of the retarder system. However, before proceeding, you should be aware that there are 2 different types of retarder operating cylinder. On earlier Tigers, a twin-air cylinder is used, and on later units, this single-cylinder unit is fitted. To check the operating pressure with the vehicle stationary, regardless of which control system is fitted, the following procedures can be used. In the case of the older twin-cylinder arrangement, connect the pressure gauge at this test point. Remove the solenoid cover and start the engine. And press the solenoid plunger in. If this section of the cylinder is now moved out, a pressure of 16 pounds per square inch should register on the gauge. Next, extend the second stage section of the cylinder and a pressure of 27 pounds per square inch should be achieved. If these pressures need to be adjusted, this can be done by lengthening the stroke of the cylinder to increase or shortened to decrease the pressure. With the later air actuator, again remove the solenoid cover and connect the gauge. Start the engine and press the solenoid plunger in. Because of the different design arrangement, this will automatically apply first stage. To operate second stage, you will be required to connect an independent air supply to the operating cylinder. If any pressure adjustment is required, there are 2 adjustments inside the end cover. This is to adjust the first stage pressure, and this screw for second stage pressure. If your vehicle has an LVA control panel fitted, an alternative method can be used to check the retarder pressures. Disconnect the second stage EP plug, start the engine, and press the foot brake. Place the change speed control in A. Next, press the test button on the control panel. In this condition, as the panel moves up through its internal test sequence, the first stage pressure will be visible. Reconnect the second stage EP plug to operate second stage. Remember, there will be a short period when the panel will shut down the retarder. However, in most instances, the panel will actuate the retarder for 25 seconds on each test cycle. If the retarder hand control switch is fitted as an alternative to the foot brake control system, because first and second stage can be switched as required, it will not be necessary to disconnect the second stage EP unit to conduct these tests. If a microprocessor control system is used, providing a special test button is available, you can adopt the following procedure. Install the test button, start the engine. Place the change speed control in A, press the foot brake down fully, or operate the hand control valve to the second stage position. To trigger the first stage, press the test button once, and to operate second stage, press the test button another 2 or 3 times. If your Tiger has a pneumocyclic gearbox, the oil drain and refill procedure is identical to that of the hydrocyclic unit. However, the oil filter is located inside the gearbox. To gain access, remove this plate. The filter can now be removed. The filter element can be cleaned and then replaced. Ensure that all seals are in good condition, both on the filter bowl and gearbox baseplate. It should be noted that the filter assembly can, if required, be removed without draining the gearbox oil, because it's situated within a moat. Gear application is by air pressure, and it is important to check for air leakage past the piston seals. Providing you have a semi-automatic control, this is carried out by engaging each gear in turn and checking for air leakage from the gearbox breather. On gearboxes with fully automatic control, only the starting gears and reverse gear can be engaged with the vehicle stationary. You will therefore be required to connect an external air supply to each of the gears to complete this leakage check. Because each of the operating cylinders has a restrictor on the air supply, if you allow the vehicle to operate with air leakage from the operating pistons, this will result in a drop in the cylinder pressure and consequent loss of clamping load on the brake bands and clutch plates, causing slip to take place. Each operating cylinder has a drain plug, which should be removed to drain any oil which may have collected. If a lot of oil is present, the piston must be removed and have replacement oil seals fitted. If the cylinders are not drained and a large amount of oil collects, the gear will be slow to apply, causing slip, and also slow to release, causing a possible short period of 2-gear engagement during the gear change. This condition is most evident when the oil is cold. The gearbox operating pressures should be checked by connecting a pressure gauge onto the reverse gear supply pipe and then selecting reverse gear. The running pressure for these gearboxes varies depending whether the controls are semi or fully automatic. Therefore, refer to the program notes for the range of figures. The system pressure can be reset if required by adjusting this limiting valve located at the front of the vehicle. The final check on the gearbox is to inspect the travel on the top gear piston. Remove this drain plug and install a special gauge, details of which are contained in the support notes, and screw it in until light contact is made with the piston. Make a note of the length of the thread. Apply the gear and screw the gauge in until contact with the piston is again made. Check the thread length. The difference in the two readings is the piston stroke. Providing this dimension is less than 1 inch, it is in order. If in excess of 1 1/4 inches, remove the piston and push rod and add a shim to reduce the travel. If you find that the push rod has shims totaling 1 inch, you should not attempt to add any more shims, because the clutch plates in the gearbox have now reached the end of their effective life and must be changed. Failure to maintain the correct travel on top gear will result in the piston reaching the end of its travel without clamping the clutch plates correctly, causing slip and possible damage to other components in the gearbox. If your vehicle has a Telma retarder fitted, you should periodically clean off any traces of mud or grease using a jet of water. Make sure that the retarder is cold when carrying out this exercise. And finally, dry off the unit with compressed air. Make a check on all cables and clips and make sure that all terminals are tight. The air gap between the rotor and magnetic pole heads should be periodically inspected. Details of this procedure are in the maintenance manual. To complete the maintenance check on the semi and fully automatic gearboxes, during the road test, check that the gearbox changes smoothly and, most importantly, ensure there is no slip in any of the gears. Should slip be identified, the vehicle should not be returned to service until this fault has been cleared. Otherwise, very serious damage could result.